Lesson 7F, Quadratic Inequalities and Max-Min Word Problems. Take a minute to graph the line y equals 3x minus 4 and the inequality y is greater than 3x minus 4. Stop the video, do those two, and then start the video again. Hopefully your graphs look something like this. What you should remember is that when you graph a line, you draw a solid line through the points. Those are the only points that satisfy that equation. With an inequality, after graphing the line, which would be dotted in this case because we do not have the or equal to option, you're going to shade the half of the graph that shows all of the points that would be greater than 3x minus 4. So that brings us to the question, what is the difference between the graph of an equation and the graph of inequality? Well, clearly the big difference is the shading. You would also sometimes see a difference in the dotted line. So these are really the two things that you're going to need to consider as you graph quadratic inequalities. To graph a quadratic inequality, you're going to graph the boundary, which is the parabola, using a dotted line for strictly greater than or strictly less than, and a solid line for greater than or equal to or less than or equal to. Make sure that your vertex is correct, as well as the other pair of points that fit on pairs of points that fit on the graph. Once you've got your parabola securely graphed, you're going to test a point that is clearly inside and a point that's clearly outside the parabola to find the region that represents the solution. One good hint is to use the same x-coordinate as your vertex, because once you know that, you don't have to do as much calculation. Every time you plug in the x value of your vertex, you're going to get that y value. You don't have to keep redoing the calculations. Once you've decided which region, you're going to shade the appropriate region. So let's do an example. Here's an equation in vertex form. So we're going to start by naming our vertex. Should be -1, 5. And since we have this -1 out front, I know that A is -1, so my concavity is going to be down. It's going to open down. So let's get this graph. -1, 5. And I'm going to open down with a stretch of 1. So that's 1, 2, 3, 4, 6, 7, 8, 3, 9. And because I have less than or equal to, I'm going to use a solid parabola. And now I have to choose points. I like to choose points that are dramatically inside and dramatically outside. We are going to stick with an x value of -1. Clearly inside, I'm going to take that point right there, because zeros are usually easy to work with. So I'm going to use the point -1, 0 for inside. For outside, -1, I want to go above it, and I'm just going to jump all the way up to 10, so there's no doubt as to that I'm outside my parabola. So now what we need to do is test these 2 points and figure out which one works. To do that, I'm just going to use my basic equation and plug this in. This says y is less than or equal to, so I'm going to write 0 is less than or equal to -1 plus 1 squared plus 5. Well, I know when I plug in -1, I'm going to get 5, and you can see that from here, because -1 plus 1 is 0. When you square it, it's still 0. You change its sign, it's still 0, which makes the right side 5. 0 is less than 5, so this does work. We're still going to test the other side to make sure that we don't make mistakes. So here my y value is 10. Since I'm using the same x value, I know I'm going to get the same thing on the right-hand side, so there's no need to recalculate. This says that 10 is less than 5. This is not true. So the inside point is the one that works, and so our shading is going to be right inside our parabola. So we're going to shade this whole area in here to show that every point inside my parabola works. Now pause the video and go do the next one on your own. Okay, problem C is in standard form, so we're going to think through different things. The first thing we want to consider are our roots. In this case, they would be at -2, 0, and 6, 0. So these points are points on my parabola. My axis of symmetry has to be exactly halfway between them. This is a distance of 8 units. So if I come back in 4 units, that's going to put my axis of symmetry right here where x is 2. So my axis of symmetry is where x is 2, which means my vertex is the point 2 something. So let's go figure that out. To figure that out, I'm going to do y, and I'm just going to use the equal sign because I'm calculating here. 1/2, 2 plus 2 times 2 minus 6. So that's 1/2, 4 times negative 4. That's negative 16. Half of negative 16 is negative 8. So my vertex is at the point 2, negative 8, right here. Okay. If you want to graph more points, you can use the fact that your a value is 1/2. So you know you'd be moving over 1, up a half, 2, 4, 3, 2, 2. 3 would be 4.5. And your next one's going to be that x-intercept right there. You can reflect these points across to get more solidly graphed parabola. Because this is strictly greater than, we're going to use a dotted line to show our parabola. And when you choose your points, I would avoid the top part because we didn't graph specific points there, but you want to choose a point clearly inside, clearly outside. And again, I'm going to stick to ones where I know if I plug in 2, I'm going to get negative 8 because that's the value of my vertex. So an inside point might be 2, 0. Outside point 2, clearly negative 10 will work. So inside says 0 is greater than. When I plug in 2, I know I get negative 8 because that's my vertex. Is 0 greater than negative 8? Yes, it is. When I plug in 2, negative 10, I'm going to get negative 10 is greater than negative 8, which is not true. So again, what I'm going to be shading here is my inside point, or inside region. And so that's going to look like this. Again, I want you to pause the video at this point and do the next one on your own. Okay, the next one that we're going to do is E, and this one's in standard form. So the easiest thing to identify out of standard form is always going to be your y-intercept, so we'll go ahead and take that. If x is 0, we're going to get negative 3, which is our constant. So I know I have this point here, but be careful because that's not your vertex. That's just a y-intercept. To do your vertex from standard form, we're going to do the minus b over 2a. So this would be a negative 2 over 2 times negative 1/3. So negative 2 over negative 2/3. Remember that we flip and multiply. That's negative 2 times negative 3 over 2. Your 2's are going to cancel, leaving you with a positive 3. So our vertex is at the point 3 something. To find the something, we just need to plug that in. So let's go do that. I'm kind of running out of little room here because I'm writing big, but that's okay. If I plug in 3, I'm going to get negative 1/3 times 3 squared plus 2 times 3 minus 3. 3 squared is 9, so negative 1/3 times 9 would be negative 3 plus 6 minus 3. Well, what that comes out to is 0. So my vertex is the point 3, 0. Okay, so this is my vertex. Well, think through about your parabola and what you know at this point. I know my axis of symmetry has to run straight through here. That means I can reflect my y-intercept across. So we go 1, 2, 3 units over to the axis of symmetry. So we'll go 1, 2, 3 units on the other side to get that point right here. You should be able to see that your parabola has a concavity opening down. You should also be able to tell that because your a value is negative. We can count more points, or again, just very carefully graph at this point. So our parabola will be solid because we have greater than or equal to. So we're going to draw a nice pretty parabola here. And then we're going to go choose our points. Again, I like to stick with an x value that matches my vertex because when I know that when I plug in 3, I'm going to get 0. So let's go with 3 Inside, I'll do my negative 10. Outside, we'll do 310. So inside, this says that negative 10 is greater than or equal to. Remember, when we plug in 3, we know we're going to get 0. So is negative 10 greater than or equal to 0? No. This one, when I get 10 is greater than or equal to 0, this is true. So what this means is that we are going to shade outside rather than inside. And our shading should look something like this. You want to try to make it clear that you know that you're shading the whole region outside. And there we go. So stop the video and go on and do example F on your own. Okay, hopefully we got that one okay. We're going to move on. We're going to do the first set of word problems, and then we'll leave the rest of these to do in class. But we'll do the first one together, and then you'll do the second one, and then we'll finish up in class. So these are word problems involving maximum and minimum. If you remember what we talked about in class, we said that the maximum or minimum value of a quadratic function always occurs at its vertex. Vertical motion problems are one of the most typical quadratic problems. These are things like you threw a ball up in the air and it came back down, or a flare, or a rocket, or something like that. So what we're looking at here is a typical formula that we can use, where h stands for the height of the projectile, and that's going to be measured in feet per second. T is time, and that will always be in seconds in this case. And velocity in feet per second. So let's look at our first word problem. A flare is launched with an initial velocity of 96 feet per second. The arc follows a parabolic path with the equation that's given here. The h is height and t is time. So the question is, when will the flare reach its maximum height, and what will that height be? Well, maximum we know is the vertex. This equation's in standard form. So we just need to do our minus b over 2a to find the x-coordinate of your vertex. So a is going to be negative 16, b is 96, so minus 96 over 2 times negative 16. That would be negative 96 over negative 32, which is a positive 3. So my vertex is going to be 3 something. Let's go calculate that. When I go plug in 3, my h is going to be negative 16 times 3 squared plus 96 times 3. And when you go calculate this, you're going to get h to be 144. So that gives us our vertex. This also gives us the answer to the first question. So what we would say is that the flare would reach its maximum height of 144 feet at 3 seconds. That gives all of the answer to those questions. So now we look at when this returns to the ground. Well, keep in mind that when it returns to the ground, your height is going to be 0. So all we need to do is set this equal to 0. We know how to solve quadratics. In this case, this is easy to factor. We're going to factor out our GCF. And we get t is 0 or t is 6. Well, that means that it's going to start at 0 and land at 6 seconds. So our answer here would be 6 seconds. Finally, we're asked to sketch the situation labeling our points. Always label your axes. So our x-axis is going to be time, and this is measured in seconds. Our y-axis is height, and this is measured in feet. The points that we have are that 0, 0. We have 6, 0. And at 3, it's at its maximum height of 144. So we're just doing a sketch, and all we need to show is when it reaches its maximum, when it lands, and what that maximum is. All right, so stop the video now, and I want you to do example 2 on your own. You should be all the way completed with your notes through example 2 when you come to class next time.